Okay, 9.3 is similar right triangles. So it says identifying similar triangles. When the altitude, okay, if we have not talked about that word yet, that means basically the height of your triangle, okay? Depends on what year you're watching this video. But if we've skipped around, that means height if we have not talked about altitudes, okay? So when the altitude is drawn to the hypotenuse of a right triangle, the two smaller triangles are similar to the original triangle and to each other. So theorem 9.6, right triangle similarity theorem, says that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Okay, so what you see here is that we really have three triangles. So we have this smaller triangle on the right-hand side, which you can see redrawn here. We have this, I guess you would say medium-sized triangle on the left-hand side, which you can see redrawn here. And then we have this big outside triangle, right? A, B, C, D. So you have three triangles there, and they're all similar to each other. Okay, so if you want, you can do some different similarity statements. So CBD is similar to triangle ABC, or triangle ACD is similar to triangle ABC. Or the last one you can do is triangle CBD is similar to triangle ACD. Okay, all of those statements are true. Okay, so now if I come down here to example 1, it says identify the similar triangles in the diagram. Now remember, it's important that we have these written in the right order, right? So what I do is I like to redraw them. So here's my small right triangle, here's my medium-sized right triangle, and here's my largest right triangle. Okay, they're all oriented the same direction, and then I'm going to go back and I'm going to label them. So if I'm looking at my small triangle here, okay, my right angle is at U, my shortest side is from U to S, and the tallest side is from S to T. If I'm looking at my medium-sized triangle now, so that left-hand side one, my right angle is still at U, but now the shortest side goes from U to T and then up to R. My biggest triangle here is the right angle is at T. The smallest side, which I didn't do a very good job making this bigger. There we go. Maybe that'll help it a little bit. It should be T to S, and then the larger side goes up to R. Okay. So then that can help me identify which way to order these. So I'm going to say triangle SUT is similar to triangle TUR. I have to go in the same order. Is similar to triangle STR. Okay, and that's all that you need for example 1. So go ahead and turn the page. Using that same idea now, for example 2, it says a roof has a cross section that is a right triangle. The diagram shows the approximate dimensions of this cross section. Find the height H of the roof. Okay, so what I'm going to do is I'm going to redraw 3 triangles again, like I just did. This time I'll make sure to draw them correctly. Okay, now I'm going to label them with their letters. Okay, so W to X up to Y is the taller side. My medium one, my right angle is still at W, but my shorter side now goes to Y and then up to Z. And my big outside triangle is my right angle is at Y. The shorter side goes to X and then up to Z. Okay, now I'm going to go back and I'm going to look at these numbers and I'm going to fill it in. So do I know XW? Let's look. XW. I don't know exactly what that is. I know what the whole thing is. So skip that. Do I know XY? XY is 3.1. I do. Do I know WY? WY is H. That's what I'm looking for, right? Okay, so WY here is also H. W to Z, I don't know because that's just a piece. Z to Y, I do know is 5.5. Okay, ZX is 6.3, and XY is 3.1, and ZY is 5.5. Okay, so you have some choices here. Okay, so you can either use, you could either use these two and solve this problem, or you can use these two. It doesn't matter, okay? So I'm going to use the second two since they're right next to each other. And I see 5.5 over h equals, okay, 5.5 matches up with 6.3 over 3.1 matches up with h, okay? You're going to cross multiply and divide, and you should get that h is approximately 2.7 meters. Okay, you could have this set up differently. So like I could have had h over 5.5 equals 3.1 over 6.3. I could have had h over 3.1 equals 5.5 over 6.3. Okay, all of those different ways, you're going to get the same exact answer. Okay, so if you didn't see exactly what I see, it doesn't mean that you're doing it wrong. I just want to make sure that you know that you can do it in different ways. Okay. Okay, so then I'm going to go on to using a geometric mean. So it says geometric mean. This geometric mean of two positive numbers, a and b, is the positive number that satisfies a over x is equal to x over b. So if you cross multiply, you would get x squared equals a times b, and x is equal to the square root of a times b. Okay. So then it says find the geometric mean of 24 and 48. So I'm going to plug it into this second one. So x squared equals 24 times 48. Okay, and if you actually multiply those out, it comes out to be 1,152. Okay, then I'm going to simplify. So I'm going to take the square root of both sides. So x equals the square root of 1,152. And I know that that breaks down into the two numbers that I multiplied by, 24 and 48. Okay, then you can keep breaking that down. Well, that breaks down into 2 and 12. 48 breaks down into 12 and 4. Okay, I ought to see a pair of 12, so I can stop there with those. 4 breaks down into a pair of 2. Okay, and then I have this 1, 2 left over, right? So I can take a 12 out because it has a pair. I can take a 2 out because it has a pair, but then I need to leave 1, 2 inside because it's all by itself. So that becomes 24 root 2, okay? Or approximately 33.9, okay? I want us to keep it in simplest radical form though for the most part, so that's what simplest radical form looks like. Okay, so if you turn the page, theorem 9.7 is the geometric mean altitude theorem. So it says in a right triangle, the altitude, or remember that means height, basically from the right triangle, the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitudes is the geometric mean of the lengths of the two segments of the hypotenuse. Okay, so if I'm looking at this picture, CD squared, so the altitude or the height, is equal to the geometric mean of the two segments of the hypotenuse. Okay, so the two segments of the hypotenuse would be AD, because that's this big hypotenuse of the big triangle, times DB. Okay, theorem 9.8 is the geometric mean or the leg theorem. So a little bit different here. It says in a right triangle, the altitude or the height from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of the triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent. Okay, remember adjacent means next to, okay, or touching, right, to the leg. Okay, so if I'm looking at that, you have two choices here. Okay, I could have CB squared is equal to DB, because that's the part that's touching the side CB, times the whole hypotenuse is AB. Or if I'm looking for the other leg, or I'm given the other leg, I have AC squared equals, well, DB doesn't touch that part, it would be AD touches that part, so AD times AB. Okay, so two different versions here, kind of depends on what you're looking for. If you're looking on something on the inside, okay, this is where your x would be here. Okay, and if you're looking for either x or y here, this is the route that you would go, okay? All right, so example 4, find the value of each variable. So this is on the inside, so I know I'm gonna do this top theorem 9.7. Okay, so I take x squared equals AD, which matches up with 6, times DB, which matches up with 3. Okay, so x squared equals 18. X equals the square root of 18, which I know breaks down into 6 and 3. 6 breaks down into 2 and 3. So I have a pair of 3s and 1, 2 left over. So x is equal to 3 root 2. Okay, now B, I'm looking for something that's on the outside of the triangle. So this is going to be y squared equals, now I choose the part of the hypotenuse that is touching y, so I choose 2, times the whole hypotenuse. I need to add, right, to get the whole hypotenuse. 2 plus, not times, plus. A lot of people do the wrong thing there. 2 plus 5 is 7. Okay. So y squared equals 14. Y equals the square root of 14. I can break that down into 2 and 7, but then those both don't break down any further. So my answer is just y equals the square root of 14. Okay. The last example here, example 5, I'm using indirect measurement. It says to find the cost of installing a rock wall into your school gymnasium, you need to find the height of the gym wall. You use a cardboard square to line up the top and bottom of the gym wall. Your friend measures the vertical distance from the ground to your eye and the horizontal distance from you to the gym wall. Approximate the height of the gym wall. So you are trying to find W. So then you can find the whole height of that gym wall, okay? So this is what I want to find when I'm done is X, but I have to find W first, okay? That is something that is on the outside of that big triangle. So I am going to use this bottom formula to help me, okay? Now where my variable goes is going to be a little bit different though, because I know this part that's, wait, hold on, let me think about this. Hold on. Okay, no, sorry. I'm sorry. We are going to use this one. I'm sorry. Because with this one, the reason why, I'm glad that I actually did this. The reason why we can't use this one is because everything that I am using here isn't, you don't use it in this one, because I have to use this middle value in my problem because it's one of the ones that's given to me. And I don't have one of these to be able to help me solve, okay? The only thing I know is the whole hypotenuse. So that is actually not the right one. Sorry that I went on that little tangent, but okay, this is the one that we actually want to use because I know what this CD is, and I'm just going to solve for one piece of this whole hypotenuse outside, okay? So what I'm going to do then is I'm going to take 8.5 squared, and that's equal to each piece multiplied together. So that would be W times 5. Okay, so instead of having my variable squared here, I think that's what I meant to start going on. Instead of having my variable squared out here, your variable can move throughout and you can still use that same formula from before. Okay, so 8.5 squared is 72.25 equals 5W. Divide by 5 and you get 14.45 equals W. So then to find the whole height, I take 14.45 and I add 5 to it because that's that bottom piece of the wall or the height of the wall that I know. So then I get that the height of the wall is 19.45 feet. Okay. And that is the end of 9.3. So you can go ahead and go do your assignment now.